Hello students, once again Sushil Gupta is back for physics classes, class 9, chapter 1 measurement. Yesterday we have completed 1A of class 9 physics. Today we are going to start with chapter 1B, that is second part of first chapter, measurement of length will be the topic of today. Whenever we have to measure any of the object, we need an instrument. So, whenever any object is to be measured, what we need? We need an instrument. So, instruments are used for measurement of any devices. For example, in our daily life, meter rule we are using. It is used for measurement of length. Whenever we have to measure, if you go to buy a cloth for your pant or shirt at the shop, then the device used by the shopkeeper to measure the length of the cloth is known as meter rule. So meter rule is the device which we are using for measuring of length. In the same way, beam balance and physical balances are the balances which are used to measure mass. Suppose if your mother tells you to buy 5 kilograms of sugar from the shopkeeper, then what type of balance he uses? He uses beam balance for measuring the mass of the sugar. In the same way, watch is used for measurement of time. As we all know, again and again we are seeing the watches. Right now it's 2:15, then 3, 4, 5. How we are able to find it out? We are able to find it out with the instrument named as watch. Same way, if we are having fever, then what we are using? We are using thermometer. So thermometer is the device which is used for measurement of temperature, whether for our bodies or in the laboratory. Same way, for measurement of current, we are using ammeter. Ammeter is the device which is used for measurement of current. So, what are these? Meter rule, balance, watch, thermometer, ammeter. All these are coming in the category of instrument. So, whenever we have to measure any of the quantity, we need an instrument. Every instrument is used for the measurement of accuracy. Every instrument is having a fixed limit, a definite limit of accuracy. It can measure only up to a particular value. A definite value can be measured by any of the instrument, and up to whatever accuracy the instrument is measuring, that accuracy is known as least count of the instrument. It is noted by symbol LC. Therefore, we can say that least count is the minimum value that can be taken accurately by any instrument. So, what is least count? Least count is the minimum value which can be taken by an instrument accurately. Okay? In other words, we can also say least count is the value of one smallest division on the scale. It is the value of one smallest division on the scale. I hope least count might be clear to you. It is the minimum value which can be accurately taken by an instrument, or we can say it is one smallest division on the scale. For example, we will be taking the example of meter rule only. Right now we have studied that for measurement of length, we are using meter rule. Is it? So, let's see for meter rule. For meter rule, the least count is 1 mm. How? We might have seen this scale. Is it? All of you might have used this scale and you might have seen that it is calibrated in centimeters. Is it? So distance between two marks on this scale is 1 centimeter. Therefore, for finding out least count, this 1 centimeter is divided into 10 equal divisions. So 1 centimeter is divided into how many divisions? 10 equal divisions. Therefore, the least count of meter rule will be 0.1 centimeter, or we can say 1 mm. Therefore, meter rule is not able to measure the length below 1 mm or below 0.1 centimeter. The more smaller will be the least count. Smaller will be the least count of an instrument, more accurate will be the results, or we can say more accurate will be the measurement. So smaller will be the least count, more accurate will be the measurement. So if we want more accuracy, or if we want to measure the thickness of thread, the thickness of paper, then can we use meter rule? No. We will be using more devices, further more devices which we are going to study in this chapter, that is vernier calipers and screw gauge. So for measurement of length, in this chapter we are going to study and discuss about 3 main devices which are used for measuring of length. First one is meter rule only, which we have discussed right now. Second one is vernier calipers. And third one is screw gauge. So these are the 3 devices which we have to study in detail. Meter rule, vernier calipers and screw gauge. We have discussed that meter rule can measure up to the accuracy of 1 mm, or we can say 0.1 centimeter only. If we want more accuracy, then we will be using vernier calipers. If we want much more accuracy than vernier calipers, then we will be using screw gauge. So now we are going to discuss about vernier calipers in detail. So let us move on vernier calipers. Now, vernier calipers was discovered by scientist named Vernier, and therefore it is named after its name only. Vernier. This device, that is vernier calipers, is consisting of 2 scales. One is main scale and another one is vernier scale. Main scale is known as MS. It can also be abbreviated as MS, and vernier scale can be abbreviated as VS. The important point to be remembered is that main scale is fixed scale, whereas vernier scale is movable scale. Main scale is fixed and vernier scale is movable. Main scale is calibrated in centimeters and vernier scale is calibrated in mm. So now we will be discussing about the least count of vernier calipers. We are going to discuss about the least count of vernier calipers. So what is least count? Least count of vernier calipers is equal to the difference of values of one main scale division and one vernier scale division. So whatever will be the difference in the values of one main scale division and one vernier scale division, that will be equal to least count. and this is also known as Vernier constant. It is also known as Vernier constant. And the formula which we will be using for finding out the least count of vernier calipers is value of one main scale division upon total number of divisions on vernier scale. Value of one main scale division upon total number of divisions on vernier scale. Value of one main scale division is noted by symbol X and total number of divisions is noted by symbol M. So the value of one main scale division on vernier calipers is 1 centimeter, we can say, is 1 mm, sorry. Whereas total number of divisions on vernier scale is 10. Therefore, the least count will be 0.1 mm, or we can also say 0.01 centimeter. So this was about the least count, value of one main scale division upon total number of divisions of vernier scale, that is also equals to x upon n, and the least count is 0.1 mm or 0.01 mm. You have to learn the formula and the numericals will be coming on this only. So if we want to find the total reading, this was about least count. Now we are going to discuss about the total reading. If we have to find out the length of an object with much more accuracy, then how we can find out? Total reading equals to main scale reading plus vernier scale reading. If we will be summing up the values of main scale reading and vernier scale reading, then it will be giving us the total reading. Main scale reading can be read directly, but for vernier scale reading, we will be using the formula P into least count. Least count we already have studied. It is fixed. Is it? It is 0.01 centimeter. But what is P? P is the number of division of vernier scale which is coinciding with any division on the main scale. So P is that division which is coinciding with main scale. For example, main scale reading is given in the question is 1.2 centimeter, and it is told that sixth division of vernier scale is coinciding with main scale. Then what will be the reading of vernier scale? So for finding out vernier scale reading, we will be using the formula P into least count. P, that is 6, least count into 0.01. So it will be 0.06. Is it? Centimeter. And for total reading, we have found it's main scale reading plus vernier scale reading. So for total reading, main scale reading is given as 1.2 centimeter, and for vernier scale it is given as 0.06 centimeter. If we are summing up, the total length of the object up to 2 decimal places will be 1.26 centimeter. In this way, the numericals will be coming. For finding out the length of the objects, you have to see the main scale reading and then vernier scale reading. For finding out vernier scale reading, you will be using the formula P into least count, and after finding vernier scale reading, you will be summing up and you will be able to find out the answer. Moving forward in the chapter, now we are going to discuss about the description of vernier calipers. What is vernier calipers composed of? we will be talking about the details. Description of vernier calipers. So vernier calipers is also known as slide calipers. What it is also known as? It is also known as slide calipers. Why it is known as slide calipers? Because it can easily slide over each other. Slide means move over each other like this. I have already told you that main scale is a fixed scale and vernier scale is a movable scale. Therefore, the vernier scale can be slided over the main scale. And therefore, these calipers are also known as vernier slide calipers. The main parts of vernier calipers are outside jaws, inside jaws, main scale, vernier scale, and strip. Strip is used for finding out the depth of bottle or anything. Outside jaws are used for finding or measuring the outside diameter length of an object. Inside jaws are used for finding out the inside diameter of the objects. Main scale can measure up to 1 mm accuracy. Vernier scale can measure up to 0.11 mm accuracy. This was all about the vernier calipers. These are the main parts. You have to learn which parts are contained in the vernier calipers and their functions also. Moving on to the another topic. Vernier calipers is not finished. Last topic of it is remaining. Sometimes there is some mechanical error in the vernier calipers. We all know that machines are not 100% efficient. They are not giving 100% accurate results. Because of wear and tear, sometimes many of the machines get corroded. So, because of some mechanical error in the vernier calipers, what happens? Zero mark of main scale does not coincide with zero mark on main scale does not coincide with zero mark on vernier scale. Okay, so if both the zeros are not coinciding with each other, if zero of the main scale and zero of the vernier scale is not in one line with each other, it means there is error in the vernier calipers. And if there is error, will the instrument give correct reading? No, the instrument will not give the correct reading. So now error is contained in it. So errors are of two types. Errors are of two types. What are those two errors? Positive zero error and negative zero error. When zero mark is not coinciding on each other, zero mark of vernier scale is not coinciding with zero mark on main scale, then this condition is said to have zero error. It means there is some or the other zero error in the vernier calipers. It is of two types, positive zero error and negative zero error. So what is positive zero error? If zero mark of vernier scale is on right of zero of main scale. For example, you can just see this is scale, this is zero of main scale and this is zero of vernier scale. So the zero mark of vernier scale is to the right, is it? It is our right hand. So it is to the right of the main scale. Therefore, this type of error is known as positive zero error. This will be known as positive zero error. And for negative zero error, if zero mark is on the left side, this is 0 of main scale and this is 0 of Vernier scale. So the 0 of Vernier scale is to the left hand side of main scale, is to the left. Therefore, this is supposed to have negative zero error, positive zero error and negative zero error. If there are errors, then how we will be correcting them? They cannot be corrected, only we can find their numerical value correctly by using the formula. Which formula we will be using? See, we will be using one formula by which we will be able to find out the correct values. That is, correct reading equals to observed reading minus zero error. Whenever there will be zero error, it will always be used with sign. So this will be the formula, that correct reading equals to observed reading minus zero error with sign. If it is positive zero error, then no problem, negative and positive will become negative only. But if it is negative zero error, then negative and negative will become positive. So this was all about Vernier calipers. Here you have to learn the description, the main parts, main functions, types of errors, how you will be able to find out the reading and numericals on Vernier calipers. This was all about Vernier calipers, and now in next video we will be discussing about screw gauge. Thank you and have a nice day.